research having to do with radios. Radios? Yes, wireless radios. And so, now are you using HDMI or VGA?
So wireless radios as opposed to?
I think
we need
MGT
VGA.
has been crashed. I use the VGA.
Okay, we're setting it up for VGA.
Okay.
Switching it across here. And let me thank the industrial partners for the walk that we have today. So it seems to be left. I'll have some.
Hello everyone. Professor Finkel's talk is very interesting. And after I hear the talk, I found that I made a mistake to this topic. I'm talking about my work rather than a tool. But I think this talk is very interesting because I talk this work to many people, and they all think very interesting. And my name is Zhao, and I'm a PhD student. My professor is Dr. Yu. And today my topic is FREDI robust RSS-based region with multipath effect and radio interface. And my topic my talk have 5 passes. At first I will give a basic introduction, and then I will talk about the basic idea, and I will show how to deal with the issues in the ideal cases, and then I will talk about the solution in the practical environment, and last I will show the evaluation result. And my topic is focused on the indoor localization. The indoor localization is well studied, and it can be roughly classified as 2 methods. The first one is range-based. The second one is range-free. The range-based have some method as the RSS-based. RSS is radio signal structure. Radio signal strength. And it can be used on the Wi-Fi, and we do not need to add any other special hardware. And the second one is the time of error, TDOA. TDOA is a very usual method used by the GPS, and every people know the GPS. But why the GPS cannot be used in the indoor localization? Because the GPS signal cannot pass the cell of the building, so the GPS cannot give us a very accurate indoor localization. And some indoor localization method also use TDOA, but it's very more difficult because the GPS from the Earth to the sky is a very long distance, and the signal can travel for a long time than the indoor. So the indoor localization is not suited for the TDOA. And some other methods as AOA. And there are some ranging-free methods as the reference-based, video-based, and pressure-based. They all need some special hardware. And in our talk, I focus on the range-based, the RSS-based, because we do not need any other special hardware. We can only use the Wi-Fi to localize us in the indoor environment. And the range-based method need some anchor, and they assume some anchor have some known location, and we can use some method to we can get the target node ranging information from the target node and the anchor node. So we can localize the target node very accurately. But the ranging accuracy is a key for the localization, because if we do not have a very accurate ranging, we cannot do localize the target node. The traditional method is almost based on the FREDI equation. And this one is the FREDI equation. From the FREDI equation, we can know the RSS and the distance are monotonic related, and give us RSS. The RSS is the received signal strength. We can compute the distance from sender and receiver very easily. But this one is I measured the RSS in the different environments. We can find for example, at the distance of the 4 meters, the RSS is a variation. It's not constant. So we cannot compute a very accurate distance by this RSS. This problem is open for many years, but I and my group have solved it. This is the same thing. In practice, there is no simple relation between the RSS and the distance. And why there is so large variations? Because between the sender and the receiver, in the ideal cases, it's just one path, it's a line of sight path. But in real practical environment, there are some multipaths. They are reflection paths, and these passes combine constructive and all destructive each other and the receiver. So we cannot. The RSS at the receiver is a variation, is not a constant because a multipath effect. And all the traditional method measure the RSS based this amplitude, like this amplitude, but they are all omit the phases part of the equation. So they cannot get a very accurate region. Our idea is, can we obtain a phases part? This figure we measure in a real practical environment. The x-axis is the channel, the y-axis is the RSS. And we find that between the same sender and receiver and the same distance in a same environment, at the different channels, the RSS is different. And we think we can get more information as the phase information from this figure. And there is a very simple solution, is a conventional fitting problem. We can fill the parameters in the Fourier equation and combine each other and get a conventional to fit this figure and get all of the parameters as the multipath disk and the reflection parameters on the different channels of the RSS. And I will talk about the motivation example. There are two passes between the sender and receiver A and B. The first, the path A is 2 meters and path B is 3 meters. And at the first channel, the phases at the receiver is all 0. The path A phases is 0 and the path B is also 0. But the two passes signal combine each other like this. This is a whole constructed. And on the second channel, the phases, the path A's phase is pi, and the path B's phases is 1.6 pi, and the signal compare each other like this. Is the other style, and it's very easy to say the two RSS is different. Two RSS is different because the reach, the phases are different. And after we show the motivation, this motivation we can get from this different is the phases information. We may get the phases information from this different. And our problem definition is all of the inputs are different channels RSS. And we can compute out the length of the shortest radio path, the line of sight path. This is our solution. In previous, I talk about we can use a very simple fitting method to compute out all the programs as the known length of sight path and some reflection parameters. But we try to use some methods as the Newton method, because the equations are equation number are very large and the parameters are too many. So there is no good solution solved by this method. And we find the Newton algorithm have a local optimize a problem, so they cannot give us a very good solution. And our solution is a little bit complex to understanding, but it can compute very quickly. I will talk our solution from the m equal to 1, m equal to 2, m equal to 3. And at here, m is the number of the passes. When the m equal to 1, there is only path between the sender and the receiver. And we can easily get the line of sight path distance d from the Fourier's equation, like here. Because there is no multipath effect, so we can get this distance very quickly. And if there are two passes between the sender and the receiver, we combine the equation like this. And we found that there is a standard trigonometric function, and we can solve it by the DFT method. This is the RSS we get from the different channel. Every channel have a frequency, and after we transfer it to the DFT, we get this. And the parameter we need to solve it at the left side, and it can get from the DFT finger like the right side. So we can easily to solve the line of sight D1 and the reflection path D2 and the reflection parameters by this equation. And if the m equals to 3 and m equals to unknown, we can get the P1 like this and P2 like this, and these parameters at here, and we can compute all the line of sight path D1. But because in an indoor environment, it is very complex, we do not know how many paths between the sender and the receiver. So okay, I'm making a mistake. Because there is no voice.
We can hear you.
Okay. I'm a little nervous. I'm sorry. Because the other receiver, as a measurement, RSS measurement is not very accurate. It's not accurate. So the left figure is the RSS that we measured on the different channels, and the right figure it is we transfer the left figure by the DFT. We cannot find the P1 and the P2 very clearly like the figure before. And some parameter, some index is very small in the right figure. We cannot, if we use it, we cannot get a very accuracy one. So we take another method. We only use the top largest amplitude in the DFT figure to solve the line of sight path. And because in the indoor environment, we do not know how many paths in the indoor environment, so the M is unknown. And we use this algorithm to estimate how many passes between the sender and the receiver. And after we get the M, we put it in the above equation. And we do some experiment and evaluation. There are 3 different environments we take the experiment. The first one is the office environment. The second one is the hall environment. The third one is exhibition environment. And they are our results. The red line is the traditional method. If we only use the traditional method, because the traditional method cannot deal with the multipath effect, and the real disk and the measure disk are not matched. But if we use our method, we can find, this is the green line, we can find the practice distance and the measure distance are matched. And how many channels we need to measure the RSS. We find from this result, we find the 16 channels is enough. And this is my work. We provide a useful method to do the reading the complex indoor environment.
So let me ask you, usually Wi-Fi access points only transmit on one frequency. if you wanted to make this practical and everyone should use it, then you would suggest that the manufacturers of access points simultaneously output on more than one?
Yes. What I designed is that because I know the Bluetooth have the more than one channels. The Bluetooth if Bluetooth can change its channels very quickly. And if we must use Wi-Fi, we can put a device like a Wi-Fi AP have more than one channels, and it can transmit information by these more than one channels at the same time. And the device, the mobile device like the phone, can measure can measure all the RSS of the different channels. I have do this experiment. It worked good. It worked good. And if they use my solution, it can measure the distance from the sender and the receiver more accurately. Very more accurately. Okay.
I might have just missed this on the slides with the equations. Were you approximating n, the number of paths, or were you solving for it and you got a definitive n? The number of paths between the sender and the receiver.
Yeah.
You said n was unknown in a lot of cases.
Yeah.
Were you, when you were actually finding the distance in the equations, were you solving for an n, where you knew how many paths, or were you making an estimate of it's probably 4 paths?
When I do the experiment, I found there are maybe 10 reflection paths between the sender and the receiver, and maybe more than 10, and maybe smaller.
Okay.
But the very effective reflection path is lesser than 10. Because, for example, I have a phone, and the Dr. Yu, and there I have a Wi-Fi, and from her to me, and there are reflection, and there may be some paths the signal to the reflection more than one, maybe reflection to the wall, then to that wall. But because every time the signal to the reflection may be weaker, maybe more weaker, and this is also a reflection, but it's not a very effective path between the AP and me. And if I communicate out the reflection path, maybe more than 10. But after I do the experiment, I found there are maybe 4 or 5 paths between I and AP. And to evaluate whether my solution is workable or not, I also design a reflection between, not between, aside I and the AP. And I try to use my algorithm to find the reflection path distance is active or not. I find this very active. I think it's similar to the reader. I can find the distance between I and the reflection things.
Does your method work if the line of sight path is blocked, so you only have reflections? Do you require line of sight as a
Yes,
baseline?
I need a line of sight. I need no block. Because if there is a block, the signal will be weaker, and we do not know how weaker. Yeah, this is the future world.
So that is one of the things you were looking at, is being able to do it without line of sight. As part of the future work, is part of that, you're definitely looking into doing it without line of sight, with a block.
I do not have an idea. I just saw open problem in the result localization, and the block is also another very difficult. without localization method. And why there is no currently used without localization method after GPI? Because there are a lot of open problems we need to solve. The block is very difficult.
Yeah.
Okay.
It seems that you need to calibrate this, even if there's only one path and it's line of sight, and you get a certain signal strength. It's not easy to convert that to the number of meters because you don't know how strong the sender is. You don't know how sensitive the receiver is.
I understand what you mean. We can find on the n equals to 1, and there is a C right here. And this is C is the sending strength and the receiving strength. It can be measured offline. Before the device, the ranging device used, we can measure it offline.
Right,
And
so-
it's never changed.
Right, for every transmitter, you know its strength, and for every receiver, you know its sensitivity.
Yeah.
I see.
So, like ideally in my iPhone, when I'm connecting to a speaker and a list of Bluetooth devices, it would also have like 3 feet, 5 feet, 8 feet.
3 feet.
Or like on a phone, so like ideally if this worked perfectly, then on a phone, when you were connecting to something on Bluetooth, you could also list the distance with the device.
Please, you mean you link the distance?
That means you could build an app which would tell you the distance.
Oh, okay, yes. I try to build an app by the Android.
Oh, did it work well?
Because but I find some problem because the Android is made by the Google, but the Google do not open for the deployment in the very low layer. It cannot allow me to change the channel to send the signal. The Google do not allow me to do that.
That might be a common problem with phones, just because of FCC regulations. They don't like the users of the phone to be able to change too much about how it works, because then you can easily create interference. Okay.
Other questions? Yeah. 30 seconds. Well, thank you very much. A very interesting talk. Thank you. I should point out that I was looking yesterday for someone to talk, and Daria, you came up just yesterday and said, yeah, I'll be glad to talk. So it's amazing to be able to, at short notice, present such a nice talk. Thank you very much. Stay tuned. Next week I'll be out of town, but hopefully something will happen.
The bug's like 4 people